Hey, welcome back, and in this video I'm going to show you how you can get started creating WebAssembly modules using AssemblyScript. Now, if you don't know what AssemblyScript is, it's a programming language that is being created, which is essentially TypeScript, but the difference is unlike TypeScript, which transpiles down into JavaScript, AssemblyScript compiles down into WebAssembly modules. So there are some differences between the languages, because obviously JavaScript is a dynamic language, whereas WebAssembly is a static language. So some of the differences that you'd have in some of the capabilities and in some of the syntax are there, but largely they are the same. So if you are somebody who is familiar with JavaScript or TypeScript and you want to get into WebAssembly modules, and you want to get into creating WebAssembly, but you don't really want to hand code WebAssembly, which, to be honest, most of the population shouldn't be hand coding WebAssembly, right? It's probably a very complex way of creating your WebAssembly modules. But at the same time, you don't want to learn another more system-based language such as Rust or Go or C or C++, then AssemblyScript is probably a great way of you sticking with your core JavaScript, TypeScript knowledge, but then being able to create WebAssembly modules using that. So we're going to get started. I'm going to show you how to get it installed on your machine, how to create some basic code with it, and then we'll compare that to the sort of hand-coded WebAssembly that you would have created if you were following some of my other videos. So let's get started. Okay, so the first thing we need to do is we need to get AssemblyScript up and running. So to do that, we need to create our AssemblyScript folder, or the modules that we want to create, and we would just do that like we would any other Node.js or JavaScript based package. So I'm going to create a new folder. We will call that Chris Math, because we're going to create some math packages today. So we'll just cd into that Chris Math, and then like any other JavaScript package, I will just do an npm init to get that started. So I'll just hit return. So that's me installed, and you can see it's created my package JSON. Okay, so because AssemblyScript is just like any other npm package, you can install it like any other npm package. So to do that, I would just type in npm install. I'm going to do a --save, and then I'm going to load a thing called AssemblyScript loader. So I'll just put that in there, and that is going to be a package that is used for creating your AssemblyScript. Okay, so we'll just install that, --save, and then it'll appear as a dependency. So that'll take a few seconds to get that installed. And in fact, if I more my package.json, you'll see there you go, AssemblyScript loader is installed in my package. So the next thing that, let's just clear that. The next thing I need to install is AssemblyScript itself. Now, in this case, I will just put that as a dev dependency, because I'm not going to need that at runtime or anything like that. So I'll put save dev AssemblyScript, and that will install that. And again, that is now in my package JSON. So I now have AssemblyScript installed on my machine. Pretty cool stuff. So now that I've got AssemblyScript part of my package, what I want to do now is just scaffold up an AssemblyScript project. And what's really cool is AssemblyScript has got this really neat npx package, which allows you just to scaffold up everything that you need, and it makes life super simple. So rather than you having to manually code all the packages and the conventions, it will just do that for you. So it's called ASInit. So you just type in npx ASInit and then dot. So we want to scaffold it into the folder we're in just now. That'll take a few seconds. I'm just going to say yes to all of this stuff. So I'll hit Y, and then that's all packaged up. So if I look at that, you can see it's created a whole set of things for me. So if I want to look at how that looks underneath, I'll just type in code dot, and then we can see how that looks in Visual Studio Code. So let's just have a little bit of a look across some of the files that is created, and then we'll talk through that, and then we'll create some of the code. So you can see there's a package JSON, as you would imagine. It's pre-built in a couple of commands. So as build. So if you do an npm as build, then or npm run as build, it's gonna build your code for you. You can see it's untouched and optimized, so you can sort of do debugging and release builds. You can kind of see we've got the dependencies that we put in before. So our package JSON is there. You can see it's created an index JSON, so it's created the code that you need. So it automatically loads the WASM file and then does an export. So it's super easy for you to go and test your code and write your code there. And that's fine. There's a test folder. So if you want to write some tests, you see it's already created a function there already for adding two numbers together. Bunch of node modules that we're going to ignore. There's a get-ignore file, and then in here is the index.ts, which is actually where you write your code. And then finally there's a tsconfig, which is just giving you the config for your build. So this index.ts is the key place where we sort of start. I'm going to delete the function that was there already, because we can recreate that ourselves and then write some tests to do that. So I'm going to create, rather than using the add two numbers, we might do that again in a second. The first thing we're going to do is we're going to create a function which will square two numbers together. So again, this is going to feel really familiar. So if we just type in export, because we want to export this function outside world, export function, we're going to call our function square. I'm going to pass in a number, so in this case it's going to be n1 for number 1, and then because it's a TypeScript, then we have to declare what our types are, and also because AssemblyScript is a static language, so we need to know what our types are in advance. There's a difference there. We can't use things like vars, and we can't sort of infer that easily, so we just need to be super declarative of our types. So in this case, I want this to be a 32-bit integer, i32. You see this maps exactly to the types that you would have in WebAssembly. So you would have i32, you would have i16, you would have f32, f64, etc. So they all map very nicely. And then of course, if I want to return a type, in this case I want to return i32, then we're good to go. And then I will create my brackets. So to square that, I just need to write my code. All I need to do is type in return and basically multiply my parameter by my parameter. So in this case, n1 times n1 is going to be squaring of that. And then we're sort of good to go. So that is my first piece of code. Now I created some tests there. So if you remember this function, I called this square. So if I go into this test file and I want to test it, then I'm going to get rid of this add, and then I can type in square, and I would expect the square of 10 to be equal to 100. So we'll come back to that in a second. So I've built my tests, and we're good to go. So what I'm going to do is let's clear all of this. And if I want to just make sure everything works okay, I can run my build. So if I do npm run as build, then that is going to run the WebAssembly folder that I created. So if I go into this build folder for a second, you can see that I've got various versions. I've got some WASM files that are now created. You've got optimized WASM. In fact, if I wanted to, let me just delete the build folder for a second. So we'll just move that to trash. And then let's run that build command again. So we'll just run that. It'll take a few seconds. It's going to create that. And as you see, it's creating a debug release and a release as well. So if I come back into the build version, then if you remember when we looked at the package.json, you can see it created a thing called untouch for the debug release and the optimize for the release, right? Really weird way of saying that. And then my build command builds basically the debug and the release version of my WASM file. So if I come back into this build here, you see that optimized WASM, which is my release version, and untouched is my non-optimized debug version. So if I come back in here for a second and we go into the build folder, let's do an ls-la, and you can see that the WASM files are fairly small, right? So this optimized WASM is only 97 bytes. So that's pretty good. And you can see the untouched version is 259. So, the untouched doesn't have any optimizations. The optimized one does. Now, if you remember the earlier versions of my videos, or if you haven't checked out my hand coding WebAssembly modules, then you may remember this or you may have forgotten, but it's kind of up to you. There is a routine called WAP to WASM, which allows you to take a WASM file, take a WebAssembly text format file, so you can hand code in WebAssembly text format. And if you're interested in WebAssembly text format and what happens under the hood, go check out my videos. It gives a lot of details of how it works, how stack machines happen, and all the and how WebAssembly underneath the hood works. So go check that out. But there's also a utility opposite to WAP to WASM, which converts WebAssembly text to WASM files, but there's something called WASM to WAT, which takes a WebAssembly module and converts it to WebAssembly text format. So actually, as part of AssemblyScript, you can see it's created the WebAssembly text version of your WASM file. So if I open the untouched version, you can see there's a bunch of stuff in there, right? So there's a bunch of goop. We're not going to go into too much details. The key part there is you can see there's a function which is called square, which takes in one parameter and returns a result of I32. You can see local.get. What that means is, again, if you check out a video, I'll tell you, but what that means is local.get just tells you to go and get parameters. So there's a parameter called $0. So it gets $0. It's going to put that onto the stack because WebAssembly is a stack machine. And then it's going to call parameter 0 again. It's going to put that in the stack. So the stack would have two items, right? So whatever I pass in as a parameter. So I pass in 10, then the stack will have 10, and then it will have 10. And then the I32 will multiply that. So it will pop off two items off the stack because the multiplication expects two items. So it will pop off both items, so that 10 and the 10. It'll do the multiplication, and then it will push the result back onto the stack. So the stack will now have one item, which in this case would be 100. And then how WebAssembly works is when a function is ended, then whatever is remaining on the stack will get popped off, and that is returned. So in this case, the 100, which is on the stack, would get popped off, and that would be returned as that result there. That's how that works. So you've got all of this sort of goop at the top here. But if I moved into the optimized version, you can kind of see that what it has done there is the function itself is the same. It does the local.get, I32 multiplication. But all of that goop that was there before has been removed, and you're just left with the kind of square function. And there's a little bit about memory allocation. So actually, this is pretty clean, right? If I was to hand code this myself, then, you know, apart from a little bit of this group that is putting it at the top there, it's not much different from what I would write myself. And again, you can kind of look at that. So I think AssemblyScript is quite an efficient way of writing code, especially for small functions. So, you know, if you've seen my video on Rust, I show you how the WebAssembly that Rust creates, you can see that there's a lot more code. There are much bigger files. I think AssemblyScript is a little bit lighter, a little bit leaner. You know, so for really small WebAssembly modules, I think AssemblyScript is a really good way of doing that. I think Rust, if you're creating more complicated things, you're going to get more power out of that, and there's going to be less limitations than you would have with AssemblyScript. But you know, but both are really great ways. But if you want to do really lightweight stuff, I think AssemblyScript is really cool. Okay, so that's how that looks. As I said before, I created a kind of a test for that. So if we come back into my test there, you see my module.square 10100. So if we were to go back into my terminal for a second, let's cd dot here for a second, and then if I was to type in npm run test, you're going to see it's going to run that test there, and then it's came back with a pass there. If I come back into this, and then maybe if I put this as 45, we know that's not going to be right, and run the test again, there comes back with an error, right, which is 100 is not equal to 45. Test failed. Hit save, run my test again, and then we're back up and running. So as you can see, I think it's a really great way of writing WebAssembly. It's probably much better than hand coding. And again, you can build things really quickly as well. So if I wanted to do more complicated things or less complicated or different things, I can put the add two numbers back in. You can I can put n1 N2, we'll have an I32 there, and then what I will do is we'll do N1 plus N2, we'll save that, and then I can come back into my tests again. This time I will do the add two numbers, so we'll call that add two numbers again, add two numbers. We'll put 10 and 10, and we'd expect that to be 20. We'll save that. We'll come back into here. Let's run my build. So just check everything works. Yep, it's all good. Run my test there, and you see it's passed. So I've now got two items in there. I could get really complicated. These are not that complicated, if I'm being honest. We could do we'll call something maybe weird add. And then what we'll maybe do is we'll do N1 times N2, and then we'll maybe square the two items together. So if I pass 5 and 5, that would add it up to 10, and then it would square it, you know. So in fact, we could even just do this as add two numbers. We can put N1, N2. There we go. Let's save that. We'll call it weird add. If I come back into my tests, we can put weird add back in here. Let's call weird add my module, and I would expect 5 and 5 to equal 100. Let's just build that for a second. Should build okay, which it does. Run my test, that's fine. So my test passed, but if I change that to 10, run test again, you see my assertion fails, so 100 is not equal to 10. So you can start building really quickly, and if I were to sit and try and hand code that, it would just take me so much time in WebAssembly, so to use in WebAssembly text format. So this becomes really kind of powerful. The other thing that's quite useful is if you actually want to look at what the WebAssembly's created as you create this code, it's really nice, because as you see, if I go into that build folder and I look at the optimized WAT, you see it's got the square function, it's got the add two numbers, so it's using i32.mul, i32 add, and then you can see in the weird add two, you can see that it's doing the add and the mul. Now this is really interesting. So even though I did some function calls there, this is probably a good example of the optimization. So even though I did two function calls there, what the optimized version has done is actually copied that code in there. So you see it's done a local.get, and then it's done an add, and then it's done the multiplication here as well. So I think that's really interesting. So you start to see the power of that optimized.wat there, right? Because that's not the same code I wrote. The code that I wrote was I call add two numbers and then I call square, but what you see the optimizer's done is it's copied that code in, and created a new sort of mega function. If I were to come into the untouched.wat, you can see that this is the code that I actually created. So you can see I've got this square, and then I've got add two numbers, and then I did this, and then I did a call. I called add two numbers, and then I called square. So there's quite a difference between the unoptimized version and the optimized version. And this is, again, probably starts to tell you the power of having high-level languages. And if you think of the evolution of languages over time, is that we started in this world of sort of writing sort of bytecode ourselves, and then assembly language came along, and then we started writing high-level languages like C, C++, etc. Well, C++ was much later, but C, etc. And then you see, as compilers have came out, they've started doing these optimizations to get better, and you can see the exact same thing happening in this very, very simple example. So I think this is really this is cool stuff, and as you can guess, there's a huge, making function calls is quite a large impact, right? Because you've got to load new call stacks, etc. So from an optimizer's perspective, just sort of combining these two things into one function is really a great thing to do there. So again, I think it gives a bit of a view into what compilers are doing also. So last thing I want to do is I've shown you how the optimization and all that kind of works. Last thing I want to do is actually just run the thing for a second. So let's have a look here. So you can can kind of see we've got this index.js that's being created automatically for us. And that's kind of cool because once I've created that package, I can just export that out and then somebody else can start using that, right? So I think that's kind of really important. Again, just to show it working, I'm just going to rename this from index.js to, we'll call it chrismath.js. Again, you wouldn't need to do this normally because it's already a package and you could just import the package and the index.js can be used as a default. But let's do that. So I'm going to call this chris.math, and then what I'm going to do is I'm going to create a new file called index.js, and then what I'm going to do is just go const math equals require, and we will take in chrismath.js. Okay, and then what we will do is just console.log, and we'll do our math.square. We'll put in 10, and then what should happen now is when I run node.index.js, then it will run our square function and it comes back with 100. And again, I can just change that to whatever. I can put 25 in there and then run that, and you can see it comes back with, let's do that again, 625, right? So if you remember, we created a function called weirdAdd2, I think it was. So we'll call it weirdAdd2. And I accept it in two numbers. So if I pass in 10 and 10, it will add those two together. So that'd be 20, and then it's squared. So it should be 400, I think, if my math is right. So if we come back to my terminal and run node.index.js, and you'll see it comes back with 400. And again, come back to VSCode, change that from being 10 and 20. It will be some other number that my mathematical skills are not capable of calculating, which is 900. So that is kind of AssemblyScript. It's pretty cool stuff. I'm gonna be honest, I like it a lot, actually. I think it's really neat. It means you don't need to learn anything other than kind of JavaScript. It produces really good WebAssembly code, and that's it's fairly optimized. So I honestly think it's one of those things that you should just start picking up and using. I mean, go check out my video on Rust. I think the code that Rust is producing is a little bit bloatier, and again, but it's more for larger production scenarios. So I can get why you would want to use Rust in a lot of scenarios, but if you're building some fairly simple stuff and you use JavaScript, then AssemblyScript is creating some really nice code, and you should just go ahead and use that. Anyway, I hope that's been useful for you. Go have some fun with AssemblyScript. I think it's great. Again, I'm not going into all the language features and differences in this. You can kind of discover that for yourselves. Maybe in a future video, what I'll do is show some more complicated examples with AssemblyScript, but I think it's cool stuff. Anyway, hope this has been useful, and we will speak soon.